I want to work through ID 1050 Practice Exam 1 with you so you can see how to solve these kind of problems. The first question says change this base 4 number to base 10. Whenever you have a base other than base 10, you build a base chart for that. So we're going to have digits. I'm going to go here. We have a decimal that we need to put in there. It looks like we need just one spot there. So there's my decimal. The column to the left of the decimal is always worth 1. And the next column over is worth whatever the base is, which is 4. We never make a base 10 table in here. We always make this other base. 1 times 4 is 4. Times 4 is 16. Times 4 is 64. If we need to go the other way, we do 1/4. And the next one would be 1/16. When we're changing from base 4 to base 10, we just get to put the digits right in here. So this is 30.2. Just line it up with the columns. This is the one where we multiply. So we do 3 times 4 plus the digit times the column's value, which is 0 times 1, plus the digit times the column's value, which is 2 times 1/4. The answer on that is 3 times 4 is 12, plus nothing, plus 2/4, which turns out to be a half, or 12.5. So it should be that answer, answer B. The next one is change this base 2 number to base 10. So we need a base 2 table. So I'm going to go ahead and make a couple of these. We're going to need 2 of them. So here is the first one, decimal point there. The first column to the left of that is worth 1. Next column is worth the base. After that, it's worth the base times the base. And that's all we need for this example because we have 3 digits. So put those digits in here. These are base 2 digits, 0s and 1s. And we do 1 times 4. Add to that 1 times 2. Add to that 1 times 1. Add these all together, and I should get 7 out of that. So we're looking for 7. The next one is a fraction, but we work it identically. We need 1 decimal point. So we need 3 for this one because there are 3 digits to the right of the decimal. To the left of the decimal is always worth 1. The next one over is worth half because this column over here is worth 2. So the fractions are on the right, so they're halves. The next one over is worth divide by 2 again. That's a 4th. One more time is divide by 2, gives you an 1/8. I just plug these digits in there. 0.101. And you do the same trick. 0 times 2 is 0. 0 times 1 is 0. 1 times a half. None times a 4th. 1 times an 1/8. Oops. Change that up a little. Plus 1 times an 1/8. Okay, so we have a half plus an 1/8, which you can do various ways. I'm just going to use this calculator right quick. 1/2 plus 1/8, 0.625. So that's 0.625. We check to see if that's an answer. Sure enough, it is. So there's the answer for that one. Now we're doing the base conversion where we go from base 10 to base 6, but I still make a base 6 table. So for base 6 then, we remember that we have a decimal point there. I've got a whole number. How many columns do I need? Well, this is a little trickier because I don't know what digits to put in here, so I don't know how many columns I need. But just looking at my answers, at most I need 3. So maybe I'll just put 3 of these in there. Right away I can eliminate some of these answers because base 6 has no 6 in it. Base 10 has no 10 in it. So there's no symbol for 6, so I can just eliminate those guys right there. It must be one of those two. We label this columns, this base 6 table. That's worth 1. This is worth the base. This is worth the base times the base, so that's 36. The next one over is 216, but I'm not going to need that because it's way too big. So I don't need this column at all. You take your base 10 number and you put it in the leftmost column that is not too big. So 46 goes here. Ask yourself how many of this column's worth goes into my number. Looks like 1. 1 times 36, remainder 10. So this 1 is the thing I'm looking for. That digit is the thing I'm looking for. Take that 10 to the next column over. Now ask yourself how many of this column goes into my number. Looks like a 1. So that was the digit I was looking for. I get a remainder of 4. 4 goes next door. Ask yourself how many 1s go into 4? Well, 4 of those guys do. So I get a remainder finally of 0. The digit I was looking for was 4. So my digit is 114. And that's this answer right here. Another trick you can do on this, if you have trouble remembering how to work it, is just take the numbers that are given down here in your answers and convert them using these steps from the first 2 problems and see if it matches your answer 46. So if you wanted to do that here, you would say, oh, well, I'm going to try 55. I'm going to try 55. So this is worth 1. So that's the decimal point. This is worth 6. I would try this out. 5 times 6 is 30. And 5 times 1 is 5. And that's 35, which is not the answer I was looking for. I'm sorry, 35. I was looking for the answer 46, so it can't be 55. So I can eliminate that guy. So that's another way to work these kind of problems. Now we have another base 10 conversion. Base 2 is my goal. So let's put a base 2 table down here. Again, how many digits should I put in here? How many columns? Well, at most I need 5, so let's do 5 here for my answers. I need to figure out what the digits are to put in here. I need to label the column. So this is always worth 1. This is always worth the base. This is worth the base times the base. Times the base again is 8. Times the base again is 16. The next column is 32, which is too big for my number 24, so that's why I didn't need that other column over there. Again, we ask ourselves, starting the leftmost column, how many 16s fit into 24? No, 1 does. The remainder, 1 times 16 is 16. That gives me a remainder of 8. So 8 goes next door. Ask how many 8s go into 8. Well, exactly 1. 1 times 8 leaves you a remainder of 0. And remember now that when you get a 0 remainder, not a 0 in the digits, but a 0 remainder down here, you can fill zeros the rest of the way, because as soon as I take 0 next door, nothing's ever going to fit into that 0. So I can just put zeros the rest of the way out. So I've eliminated these answers and found that one to be the right one. Okay, fill in the missing counting number. So I'm going to erase some of this. You look at this problem and it says I need to find out what number goes in this blank. I'm not sure what base I'm counting in. But I do know that I'm not in base 2 because I have 2's. There was no 2 in base 2. Am I in base 3? Well, I've got a 3, so I can't be in base 3. Can't be in base 4, so maybe we ask, are we in base 5? Well, what are the digits in base 5? There's 0, 1, 2, 3, 4. There is no 5 in base 5. So my pattern when I'm counting in a different base is as soon as I hit 4, I have to cycle back to 0 and carry the 1 to the next column. So do I have that pattern going on? I have 0, 1, 2, 3, 4. Go back to 0, so maybe that should be a 0, and then I have a 1. So it seems to match that pattern. So I'm looking for my answers that have a 0 at the end. It can't be those two guys. In this pattern then it should go 0, 1, 2, 3, 4, 0. Carry the 1 to the next column, so it should be, instead of 2, 1, it should be 2, 0, it should be 2, 1. And that sure is one of the answers that I have in my list there. Okay, do the indicated operations. I'm going to do this again on the calculator. I have 10, which is negative, minus 11, which is negative. It equals at the end, and I get 12. That can't be right. I must have done something wrong. We do 10, which is negative, minus 11, which is negative. Okay, so it becomes a plus a positive, gives me 1. Okay, good news. That's in the list. Okay, the next one, just type this in like it says. We do 8, which is negative, times 2. Again, it equals at the end. That's what the parentheses tells me. Divide that answer by 4, which is negative. I should get 4 out of that list, which is right here. And that's good news.